Welcome to part 2 of my CCIE Lab series. In this video, we're going to go over DNA Center, ISE, and finish up our SD-WAN from the first part of this series. I'm going to start by going over my physical lab topology because the next few slides are going to go over how we're going to integrate DNA Center and ISE, and it's important to understand the underlay of all of that, so if you're building this yourself, you know what you're getting yourself into. So the server on the left here is my server that runs CML primarily. It also runs a Windows Server VM, but all that Windows Server VM does is host DNS, DHCP, and Active Directory for the host onboarding sections. That VM is really small, and you could run it on your workstation if you really needed to. But this server is really here for CML. So CML has most of these servers' resources, and that is what we have been primarily working in part 1 of the series. Server 2 we haven't touched yet in part 1 of the series. This runs our DNA Center and our ISE, which we haven't installed yet. I'm going to take you through the install of DNA Center and ISE in this video on this server. So these servers are exactly the same specs. If you want to run DNA Center, you're going to have to get something similar, and CPU core count is really important. So the specs I've put on the screen are the lowest specs that I can get DNA Center to run with. 40 CPU cores, 150 gigs of RAM, and 600 gigs of storage. Anything less than 150 gigs of RAM, you have containers start to crash. Anything less than 40 CPUs, you experience the same thing, as well as just some general slowness. ISE, you can take the specs of ISE down really low, and it really doesn't care. It just takes a long time to boot. But DNA Center, you really need something powerful to run it. I would say if you have money for one good server, use that for your DNA Center server, and then get something a little cheaper for the server to run your CML and your like supporting VMs like your Windows Server box. The bottom of the screen are the 3 switches I use. I actually use the 48 port model of this switch, but it really doesn't matter what you use. The one on the left is my Underlay switch, so that just connects my two UCS servers at the top there. It trunks between those so that the port groups on each other can talk. And then it also connects my Fabric Edge nodes back up into my CML topology with tagged VLANs. We'll get into that in the next slides. Okay, so this slide is really the one that I'm excited about because I don't see it put on paper much anywhere. So the top is the physical and the bottom is the logical. So on the top you can see my 2 servers from the last slide, the first one running Cisco Modeling Labs, the second one running Cisco DNA Center. And on the left side you can see my 3 switches. So the switch in the middle could really be anything. It could be a Netgear switch, it could be anything, as long as it can do VLANs so that you can isolate your Fabric Edge nodes and your VLANs between your servers. And then the nodes on the right are if you want to do the hybrid SDA Lab approach where you have some nodes virtual, some nodes physical, and we'll get into that in the next slide, what your options are for that, because you could virtualize all of SDA. This topology is my recommended setup that I think is the most effective cost-wise and performance-wise. I really think virtualizing everything really isn't all there yet, and I'll show you why in the next slide. On the bottom of the slide, you can see my logical diagram. So we have a connector in CML, and that connector is how we drag DNA Center and our edge nodes onto our topology and link them into our transit lab to connect them with our SD-WAN, our DMVPN, and our MPLS. Then that connector on the back end of CML, because CML just runs on Ubuntu, is a Linux bridge. So in this instance, it's BR2. So that connector is just bridged into BR2, which is bridged to a physical NIC on the CML VM, which is in a VMware port group. So you can sort of follow that line from left to right on the bottom. Once we're in the VMware port group, we are connected via a physical Ethernet cable to this underlay switch. So this switch down here is this switch up here, and then this server here is this server here, and these are these. So this sort of just shows you how from inside the topology, how we get to outside the topology, whether it's to an edge node or to our DNA Center and ISE. And this over here, these are tagged, so we'll be able to have multiple clouds that don't talk to each other, and we'll get into all that in this video when we get our external connectors into CML. So let's talk about your options. I've talked about how I set my lab up and how I ended up here, but I want to show you the other options because that might not be the best option for you. But these are really your 3 options that I would say are viable. There are more options and you can sort of mix and match, but I think these are the 3 main options that I see people doing. The one on the left is the most physical you can go, right? So you have your DNA center running on a server. You have your control plane or border node as a physical switch or router. You have your edge node as a physical switch. I don't think you need to do this. If you have stacks of 3850s laying around, sure. If you are more hurting for virtualization space than you are for 3850 or 3650 switches, then sure, the physical route, my order of preference here, I would say do the hybrid route. If you can't do the hybrid route, do the physical and then do the full virtual. So the hybrid route is you run your control plane and border node inside of CML, whether it's a CSR 1000V, Catalyst 8kV, or if you have a reason to run it as a 9kV, you can. I wouldn't. It's very heavy, and the data plane virtualization is really slow. But your edge node is still in the real world. This is my recommended setup. And actually, above my head over here, I have my physical switches, my 3850s. Because I have a laptop, a little like Microsoft Surface that I'll plug in up there in the next video when we do host onboarding, that will actually test host onboarding and EAP authentication and stuff like that. And it's really hard to do that if you use option 3 here, which is the full virtual approach. The full virtual approach, you're running your control plane and border inside of CML, but you're also running your edge nodes inside of CML. So you're running a Catalyst 9kV, which is a virtual iOS XE switch, and everything is virtualized. You have no physical switches, which makes it a little hard. And also, you might think this is the easiest route, but the Catalyst 9kV virtual machine takes 24 gigabytes of RAM, and you cannot go less. If you try to go less, when it tries to decompress the image, you'll get an error that it ran out of memory and it'll reboot. So if you go the full virtual route, you need RAM for all your border nodes and you need RAM for all your edge nodes. So 24 times the amount of edges you want and about 8 times the amount of borders you want. You would need a few hundred gigs of RAM just to virtualize what you could put on a 3650 or 3850 switch if you have multiple fabric sites. In this video, we're going to do both. I'm going to show you how you can do the hybrid approach, and I'm going to have a site that does do the full virtual approach. So the next slides are about the full virtual approach because honestly, in my opinion, that's the most complex setup. It might seem easier, but it's really not for this reason. You cannot use the Catalyst 9kV images that are built into CML. They will add to DNA Center, and they will show as unsupported nodes, and you won't be able to provision to them. This is because DNA Center, at least the version that I use, does not have the device packs for the version of the data plane that's in the CML images. So you have 2 routes. You can use Terry Vinson's image he's another YouTuber who does SDA stuff, and he customized an image that the serial number will randomize itself. Because the next problem you'll run into is the serial numbers by default are not unique, which means you'd only be able to add one of them because DNA does a serial number check to make sure that all your node serial numbers are unique, and it won't let you add a second one if you already have one with the same serial. So the first option to overcome that issue is to use Terry's image, which he has on his YouTube videos for download, I believe. The second option is you find the compatible UDAP image on your own. UDAP is the version of the data plane that's compatible with DNA Center. And you change the serial number in the Bootstrap config file, I think it's called switch.xml or something in CML, every time you provision a node to something unique. So I usually use the host name. And the next slide shows you how you would do both of those. So if you're going to use Terry's image, you need to take, there's a line in here by default, this line, you need to take that out, or this will take precedence over the work that Terry's done to randomize that. So you need to take that out of your node definition if you want it to randomize. If you want to manually ensure serial number uniqueness, which is what I do, you keep that line in, you flip the switch to editable, and you change this to something unique every time you drag a node on the screen. I do that. I just like having my serial numbers be my host names. But that is what I do. So that is enough for the PowerPoint part of this video. We're going to jump back into the topology, and we're going to finish off our SD-WAN work. We're going to get our templates created for our branches. We're going to get our TLOC extension going, and then we're going to get our intra-site routing up. As soon as we button up those final things, we're going to put this plan into action and get our DNA Center and ISE into our topology and start building our fabric. Okay guys, so we're back in the topology. The first thing we have to knock out before we can get to any of the SD access or DNA Center stuff is finishing up all the transports. So the first thing we're going to do is get all of our edges in template mode. So we're going to get a device template assigned to each device. What we'll do is we'll make one master template, and then we'll clone that template for each device. So every device has its own template, but it was made from the template that we started from. So we'll start in vManage, and we'll go to templates and device templates, and we'll create a feature template. All of our edges are Catalyst 8000 Vs, and they're all SD-WAN edges. So in regards to the name, I try to stay very consistent because it can get really confusing if you change this up too much between nodes in the same vManage, and then you're sort of relying on looking at the node and tracing back, okay, this template is linked to this template, and it's really hard if you don't start in an organized manner. So let's sort of split screen here so that we can see both at once, and we'll start in the order we deployed them. So we can start on our DCC edges. So this is actually going to say DCC edge 1 device template. Okay. So there's some stuff we're going to want to change in our default template, and we're also going to take this opportunity to get our service VPNs put into our device template, because we're going to have the same service VPN at every site. So if we just do it now before we make the clone of this template, it makes it a lot easier. We don't have to do it like 8 times. All of this stuff is good. Just be aware if you use the Cisco AAA template, it's going to set your C-Edge console passwords back to admin. So just be aware of that. And also, because this is the Catalyst 8000V, it's going to lock you out of the console once we deploy this. So we're going to have to make a CLI add-on template to regain our console access. So we'll do that before we actually deploy this to every node. So I'm also going to create two VPN 0 templates and 2 VPN 0 interface template. So this can be our global VPN 0 template, because there's not really much change across the C edges. If you're running dynamic routing protocols across your transport sides, you need to sort of switch this up a little bit, but you really don't need anything special in our lab. So we're just going to need a default route, and the next hop will make a variable so that we can define it per device. So this is VPN 0 next hop. And then don't forget to hit add again, or that will never show up. We don't want to do any NAT yet. I think we'll do that eventually, but I think other than that, we're pretty good. We just need that IPv4 route, because right now all we have to do is basically match what we have on the device in a device template, because we did all this stuff in the CLI already, but to convert it to template mode, to feature template mode rather, we have to redo it in the UI so that we can push it down, and then we'll look at a diff and make sure we're not undoing anything that's going to break our connectivity. So now we have that global VPN 0, but we need an Ethernet template for the interface. So global VPN 0 interface template. And the reason I'm making these global is because when we copy the device template 8 times, it's not going to copy all the sub templates. So these are still going to be linked to, one copy of this is going to be linked to every C edge, and this is going to be the master copy. So if we wanted to change anything per C edge, we'd have to copy this again and change the link in the device template. So this will get you. Make sure you change that to not shutdown, and then I believe, let's look at our lab here. I'm trying to figure out if I need to make that a variable. Did we use G1 for all of our uplinks? Because if we did, we can just hard code that. Yeah, we did. So we can make that gigabit Ethernet 1, and that won't do us any harm. Now this is obviously going to have to be a variable. And obviously this is going to be a tunnel interface because it's on the transport side. The color, this is going to have to be device specific because we have some MPLS branches and some internet branches. We don't want to restrict. I think all this other stuff is normally good. Sometimes you have to change the allows if you're doing, I think it's BGP that's off. Yeah, so if you're doing BGP on your transport side, you have to change that. That looks pretty good for now. And once again, we'll do a diff and we'll just make sure we're not going to lock ourselves out here. I am going to use this opportunity to create our service VPN. So this is going to be global VPN 100. So we'll just use VPN 100, completely arbitrary, but and you literally have to do almost nothing here, unless you want to put protocols back into OMP. Usually I add connected here, although I think that might be default. But when we do the internal branch routing, we'll come back to this and we'll probably copy this template because this is one of the things we'll need to customize for some of the branches. We don't need to put any routes down on the service side, so that's all good. We can pull that over here, and then we'll make a Ethernet interface under here, create a new template. It gets kind of confusing because you're now creating a template inside of creating a template inside of creating a device template. So you're 2 feature templates deep inside a device template. So it does get a little confusing. You just sort of have to get your bearing and know where you are. So this is going to be our VPN 100 interface. We don't want it shut down. And I believe we use gigabit Ethernet 2 for all of this, but let me just make sure. Oh no, so we can use, let's see what we got. We can use 4 because I'm looking at our TLOC extension site and I want to make sure we don't interfere with what we already got spun up for the TLOC extension site. So this is obviously going to be VPN 100 ADDR. Okay, this is not going to be a tunnel interface. It's on the service side. No VRRP yet. And save. And add. And then we're going to need to make a CLI add-on template. Trying to remember what the correct verbiage is. Let me just find it here. I should have just went with what was in my head. It's exactly what I was thinking. Platform console serial. So that is what we need to add to enable our console. If you're using CSR 1000V, you can skip this step. Cisco, in their infinite wisdom, decided that if you put a Catalyst 8000V in controller mode and actually apply a template to it, you lose all ability to do any sort of commands on the box. So this will fix that. So we'll change this template name to enable CLI. Let's make sure that applied. Okay, so now that that's enabled, or now that that's created, let's copy it. Actually, we don't need to copy it because we already made it DC. We named it something. I thought we named it a template name. So let's just attach, and we'll see if we need to change anything. And we got to fill all these variables out now. The easiest way to do that is to just pull the box up. Of course, smart licensing warnings. Let's just do this, show IP interface brief. We'll get this stuff first. So this is the VPN 0 address. And then the next hop. And then this is biz internet. And then this is going to be the inside network. We're going to actually have to derive that, so I will wait until we can do that in a second. Let's just get all the easy stuff in here. And then show SD-WAN run system. I think you can use that. Yeah. So we got this as our system IP. Oh, this is our system IP, and then our site ID is 100. So we have to figure out what we want our inside routing to be. So that would be, oh, we don't even have the link in here yet. So that would be this link and this link on the next one that we do. So I think I used 172 addressing purposely in my last run of this lab, because then it's pretty identifiable if you use your 172 addressing for your data center transits. So we'll do 172, 16, 11 because it's C edge 1 going to DC 1, and then we'll do 0/24. We'll make the DC side .1 for everything, and then the actual router for the transports will make that .2. So let me actually just copy that so I can put it here. And this is where we'll see if we made any mistakes. Okay, so it's obviously going to change a lot more the first time you deploy a template. This is the hardest time to identify like mistakes and stuff, because there's so many differences the first time you apply a template. There's just some standard stuff that even if you applied an empty template, you'd get all this stuff. And so far I'm not seeing, like, it subs the encap command out for one with a wait after it. But as long as it doesn't touch like the color, or it's going to change your admin password back to admin. It's not touching the host name. It's not touching our default route, and it's not touching our IP address. So right there we know we're not breaking our connectivity, which is good. We are adding our service side handoff, so that's good. And I just want to make sure. Okay, our platform console serial command is there, and it's already there. It's unchanged, but it would have removed it if we didn't put it there. So let's hit configure, and then we can sort of watch from the CLI. It's going to start logging in. Now we just want to make sure we don't lose our BFD sessions or anything crazy after this template applies. So once we see this go green, we'll check those BFD sessions again, because BFD is like the first thing to go down when something's wrong. If those don't go down right away, we're pretty much in the green. I mean, obviously that's just testing connectivity to other sites. It's not testing connectivity to like vManage, but it's good enough for me. If that's still working, it's most likely still talking. You know, we probably haven't changed anything that's major. This is going to take a minute. So we're going to have to copy that template for every one of our C edges, fill in the variables, and then we'll be in a spot where we can start to do things to our C edges in the GUI because they're all in vManage mode. We're also going to have to apply a CLI template to vSmart so that we can, if we wanted to actually start using this lab to do labs, like to follow along with the SD-WAN books and stuff, you need to be able to apply templates and policies to your vSmart, which you can only do if it's in vManage mode. So we'll get there too. But this is now showing success, so let's just check those sessions again, and it looks like this column here, they're all up, so that's good. Now that we know we have a template that works, we can sort of just rinse and repeat those steps. So let's go to device templates. So you can see, like, here's the all the sub templates we made, which are just all global, and then here's our device template. So now we can copy this and change it to DCC Edge 2 device template. And we can move a little faster now because we know it's working. We don't have to really pick it apart, and we're also not going to be recreating all those sub-templates. The thing that's going to take the longest amount of time is filling in the variables. One thing you can use to cheat is autocomplete with the last C edges data, and then just change stuff, because this is going to be mostly the same, right? I don't know why that won't fill in. But let's just make sure that our assumptions were correct there and we didn't do anything weird last video. So yeah, it is .14, 101.114. Okay, 101.114, 101.1.1. Let's update that. Let's click next and configure. While that configures, I'm going to go back here and I'm going to document that we made that other one 12. That's the service side. I'm going to clean these up in between clips. I'm going to clean all the labels up just because I don't feel like doing that on camera. It's a little tedious. Then I'll have a lab for you guys to download at the end with all the stuff pre-labeled, because that's honestly not a skill you really need for the lab exam. I'm not going to see this through. If it doesn't attach, you'll actually get a red error right here, I believe, and it will also, there's a column. I think my screen's a little bit too small. Yep, this will change to 1. Yeah, so we know it succeeded right there. So let's keep copying this. So we're gonna copy, and now we're on to our headquarters. I thought we were onto our branches, but we're actually gonna have to pivot over here, and we'll make this HQ C Edge 1 device. Ah, I realized I named that wrong. Let's edit that. That's the wrong one too. So that should be HQ C Edge 3. Because when I first started labbing, those numbers would be subjected to the site. And then I realized that becomes very, very confusing. So I started numbering them, the location, and then a unique to the entire topology CH number, so it wouldn't be as hard to trace. So let's attach our headquarters C Edge. Because for stuff like system IPs, if they're not globally unique, you're really not doing yourself a favor there. I think we made this 101. These are going to have to change. Do we have a site ID? No. Let's console in and just make sure we get this stuff right. But I do know 126.131 126.132, and we're gonna have to derive that somehow, so we'll wait, and it's 110. Glad we checked. Okay, so we need something to put on the service side here. The last time I did this, I sort of did 10 dot the site number dot then I started at 1.0.1. Okay, because there's going to be multiple networks per site, so by giving them all a /16 per site, it saves us a little time when we have to think of these in the future. And we'll hit configure there. Okay, that task submitted. Now we can move down to our branches. Okay. So I guess we'll work left to right here. So CH 4. And we'll copy this. And we'll use our naming convention here. So this is branch 1, CH 4. Actually, I don't even think we need to edit anything there. I think we can just start attaching. And if you have two branches that are going to be exactly the same, you could technically use the same template. The problem is then if you want to change anything on those C edges different from each other, you have to do this anyway. So I just do it all this way from the beginning. I believe this is, yeah, our only MPLS C edge is at branch 3, so we'll deal with that when we get there. This would be 10.1.0.1.1, and then this would be 126.141 and 126.142/24. Okay. Okay. Now we will copy that branch template again, make BR2CH5. Okay, edit that template. Oh, actually I keep doing that. We don't need to edit that template. We just need to attach it. Oh, it's too fast for it. Okay, 102. And we need our host name. And then this is still biz internet. And then this is 10.102.1.1.24 126.151 126.152. Update, next, configure. Okay, 3 more to go. 3 more to go. So this is BR3CH6. Not gonna hit edit this time. And 103. So the last one was, I'm just gonna make sure. forget about the nuances of parsing the SD-WAN output. Okay, yeah, it's 10.103.11/24. Then this is this is MPLS. Okay, so this is 10.254.6.1. 10.254.6.2/24, and this color is MPLS. This is 6666. The site ID is 103, and this has got to change. So this one we might want to keep an eye on. Well, actually, let's keep an eye. Let's just do the diff now. That way we're not playing with fire here. While that's doing that, I'll get logged into this one. I got that wrong. Okay, let's take a look. I'm more interested in the red. Okay. I think we're good. Let's just, yeah, okay, we're just using default routing at this site, so that's fine. Okay, yeah, that should be pretty normal. And then we'll copy this BR3 CH7. For some reason I don't see BR4CH8 in this list. We'll have to deal with that coming up. So this is where it gets a little confusing because it's going to be 10.103 21/24 7777 7 is internet 126.171 126.171 and 126.172/24. Okay. Interesting. So this is saying something else is using that system IP. I wonder if that's related. To what we're seeing here. Let's just see show run section. Show run. Just make sure these are, oh, they're swapped. Oh, they're duplicates. Okay. Let's fix that. And hope we don't have to re-enter all those variables once we do fix it. This is going to tear down all of our vSmart peers. I'm just wondering if we're going to have to redo all of this, or if it's going to dynamically realize that it is no longer if it is, we can just change it to like 77770 for now. Yeah, we'll do that. It's gonna change. It's gonna bounce basically all the control plane sessions on CH7, but now we should be able to see CH8 when we go to create a template for it. So let's, that's our MPLS only branch. Okay, so let's copy BR4 C edge 8. Okay, where'd that go? Here we go. Can we attach to, yes we can. Okay, so that was related to what I was seeing. Okay guys, whatever you do on your lab exam, do not do that. Those two duplicate system IPs, that was terrible to try to resolve. I'll tell you what I did basically though. So, I'm sure as you all saw before I cut, what was happening was vManage was seeing both of the routers as one basically, and when you would apply a template to one, it would try to apply it to the other. So I went back onto the CLI and corrected the duplicate system IPs, but then vManage was just seeing the one that had changed as down, and it was still seeing them as duplicate IPs because it saw the changed one as down, and it couldn't pull the new system IP. So I ended up having to reload both of the edges that had the duplicates, and then I went into the templates that were applied to them and clicked change config values or change template values, changed nothing but redeployed them. And I think we're all good now. So whatever you do, don't do that in the lab because that was easily like 10-15 minutes of time, and you don't have that time. So be very careful with system IPs is what I just learned there. But I did get all of the other templates attached. Well, there was only one. So I got the C edge 8 template created and attached. I'll expand this so we can see they all have one device attached, including the C edge 8 template. There was nothing different, so I didn't record it because I did it while I was waiting for C edge 7 to reboot. Next, we can start working on our TLOC extension. This is where it's going to get kind of confusing with all the different templates because we're going to need different templates for this. What we'll do is we'll start on C edge 6, and we'll extend the device template over. And there's some routing nuances here, and we'll get to those because the astute of you might be thinking, like, how are our service providers going to know these links are here? And in the real world, you'd need to be running some sort of dynamic routing protocol, or I know I've had instances at work where service providers will just stick static routes in their environment towards like a serial IP or one of the IPs on your CPE box. But I'll show you what we're going to do. But let's get the templating stuff sorted out first. So let's start on the C edge 6 template. So another reason to name them like this is you can type in CE6 and see the template for CE6 instead of trying to parse all of that text with your eyes. What you're going to need to do is so they're going to need two, because they're going to need two more interfaces in VPN 0. One to extend its TLOC, and one to receive the extension from the other C edge's TLOC. Now, you can use tags to do this. You can use one cable, and you can use sub interfaces. There's a reason I don't do that, and it's because on the CSR 1000V, when I was testing this topology out for this series, I could not get that to work. The first TLOC extension would work. So if you had a link and you tagged over it, the first TLOC extension I would do would always work. But then I would go to add a second subinterface, a second tagged subinterface, and that TLOC extension would never work. And if you did a packet capture like right here in the middle, you would see like nothing was coming through with that tag. And if you debugged the packets, you could see the router thought the packets were leaving the interface, but the packets weren't actually leaving the interface. It could be a virtualization bug. It could be something special that was on the CSR 1000V. For all I know, it could work with the 8KB, but I wasn't going to try it again. Plus, I think visually this is easier to learn because you can see the distinction in the two extensions, as opposed to a tagged interface, which I'd probably have to then show you like what that would look like logically. So I think this is just easier to do. I would practice the other way though too, and I do have some plans to maybe try that again with Catalyst 8KVs, but for now we'll just do it this way. But like I said, we need two more VPN interfaces here. under the transport VPN, not under the service side. This is all under VPN 0. So let's first create a new template, and we're going to call this global TLOC extension. We're going to try to use enough variables in this that we can make this global. So shutdown is no. Interface name will make TLOC extension downlink. And I'm using the downlink verbiage because there's a big difference in I'm extending my TLOC down to another C edge, and then I am using another C edge's TLOC to get to a transport. That interface is configured normally. This interface is different, and I'll show you what I mean there. So this is going to be static, or sorry, this is going to be dynamic. So this is TLOC EIP, and so the actual, let's take a look over here. So say I'm extending this transport, my MPLS transport, over to C edge 7. We're going to use GE2 to GE2 for that, right? So on this interface here, this is the TLOC extension interface, not this. This is just a normal VPN 0 transport interface in the MPLS color. That's it. Which is why you don't really have to do anything special there. This is not a tunnel interface. If I am the one doing the extension, my extension interface is not a tunnel interface because I will not be forming tunnels or BFD sessions off that interface. So this tunnel interface we leave off. We're not going to use that. But what we are going to turn on is TLOC extension. And this is the interface of the uplink. So we are extending the TLOC of GE1 over to TE2, or GE2, sorry, for C edge 7 to use. So that covers extending. So we've figured out GE2. Now what about receiving? For this, we can pretty much, we could use the just another global VPN 0 interface, but let's do this. Global TLOC extension uplink. This way, when we do the variables, we can name these differently, because I think it would be very confusing to not name them differently. I hate how it does that. TLOC E uplink. TLOC E uplink IP. And this is going to be a tunnel interface. And the color is going to need to be customizable to the TLOC E uplink color. Everything else you shouldn't need to change. So we've now added these two new VPN interface Ethernet subtemplates under our VPN 0. So now if we click update, we're going to have some variables to change here, because we've created new variables that we need to fill out. So this is in relation to C edge 6. So the uplink is going to be whatever this guy is sharing. So that would be Gigabit Ethernet 3. And the uplink address is going to be 126.162/24. The uplink color is going to be Biz Internet because we already have an MPLS link right here. The interface name for the downlink, so now we're going on to extending the MPLS over, so that's going to be Gigabit Ethernet 2. And the IP address for that is going to be 10.254.7.1/24. Let's just make sure that nothing fails validation here. We can actually just spy on it a little bit, and as soon as it starts to pull, we know it's, yeah, okay, so validation succeeded. That's all I need to see. Generally, it's safe to move on there unless you have reachability issues within your topology. So let's now edit 7. And what I want to do is get some baseline data here. So let's jump on 7. We applied templates. So our usernames are now admin because we used the default AAA template right here. Let's just, well, actually, we can just look at it. See how all of these are biz internet, and some of the destinations are MPLS, but none of the sources are MPLS. We are going to want to be able to source tunnels from MPLS, and let's grab that same baseline from C-Edge 6. I was just making sure I'm looking at the right one here. So obviously it's going to be this way, but I just want to show you guys the way that I validate this. So obviously all the sources here are MPLS because right now it only has an MPLS transport. So what we're going to want to see is a mix, 2 tunnels, because we don't have restrict or groups configured. So we should see everything meshing over those 2 tunnels. So we got to do the same thing here. 2 of these templates. I wish it would put the default ones at the bottom because it's really annoying. And it didn't even select. Okay, TLOC E uplink and a TLOC extension downlink, which probably should have just named TLOC extension downlink. But this will work too. Okay. So now we got to look at it from the other perspective. So the downlink from the other perspective is 10.254.7. Actually, yeah, so the downlink is 10.254.7.1. But this is the interface name. So this is gigabit Ethernet. So these would be reversed. So you can see how it's, even with 2 and not tagging, is very confusing. So the downlink is going to be, in this case, gigabit Ethernet 3, and the uplink is going to be gigabit Ethernet 2, because we are uplinking to MPLS through this link, and we are downlinking from iNet over this link. So the uplink is going to be 10.254.7.2. Because this already has a biz internet connection, so this is getting an MPLS connection. And then the downlink is going to be 126.1.6.1. Okay, yeah, I should have named that variable better too, but okay. Now this is not gonna work right away because remember what I said, those routing nuances? Those are gonna hit us here. I just want to get these templates deployed first. Okay, validation success. Now let's deal with the routing nuances. So we'll deal with the MPLS side first because it's arguably more complex. So let's look at the VRFs. Okay, so customer A is the only one we have. So IP route VRF A. Make this a little smaller. 10.254.7.2. Actually, it's reading a little bit too literally there. 7.0. And then next top is 10.254.6.2. And then don't know if we have that redistributing into BGP. No, we are only redistributing I want to make sure we only have that one route before I redistribute static. And we do. We only have that one route. So redistributing static unconditionally isn't going to kill us. Now, if that worked correctly, we'll check the other PE just to make sure, because I feel like if we spend a little time to look now, it could save us a lot of time trying to figure out tunnel reachability issues later, or down BFD sessions or something like that. So we should see 10.254.7, which we do. So now we have to do the same thing for the internet router, which is easier because it's not VRF aware. IP route, and this would be the 126 network 126.162 255 255 and I did the same thing again. And this would be 126.172. Okay. And we'll just save configs. Okay. Let's go back to CH6 and CH7. We don't yet see anything sourced from Biz Internet there. We don't yet see anything sourced from MPLS here. So the reason why is because we need to put in another static route. I did forget a step here, which means we're going to need to copy a template again. So this global VPN 0, we're going to need to copy this global VPN 0 TLOC extension. Or we could even just call it dual WAN, but I don't really have any other sites that would use that anyway. So this is going to be a really simple modification. All we need to do, well, really simple if the vManage UI didn't suck so bad. Okay, so all we need to do is add another static route with a dynamic next hop of TLOC uplink next hop. So now we'll have two. Sorry. You don't want to do that. You just want to add another next hop. So that's my bad. Forgot there was a little bit of a hierarchy here. Okay. Now we need to link that. So under the device templates, we need CE6. And we'll just sub out our VPN 0 template. Luckily, it'll keep the values because we didn't change anything. We just need to put in our new uplink. So TLE next hop is going to be 126.161. Okay, we got to do the same thing for the other one. So this is CH7. So now we're working over here. Edit. Swap this out. I'm going to just fill in that one variable. On this side, it's going to be the MPLS, so 10.254.7.1. So this is going to be the first one to actually work, I think, because that's the one we did first. And if if this doesn't work, we can start to do some troubleshooting, because I can't think of anything that would prevent us from forming tunnels from the biz internet transport on this side. Let's just do that would prevent it. We're not installing that other show run I. Okay, it's there. Ah, we didn't change that one template. So we should probably check both of these. Okay, we did that one. We did not change this one. Remember in the beginning of the video when I said that'll get you? Yeah, that's because I do it all the time. Just telling us that we have two devices that this is going to change, hopefully fix. Let's get that command back. So our goal is we want to see things sourced from biz internet to biz internet while maintaining our MPLS sourced tunnels. Oh, there we go. Now we see they're down, so we want obviously all those to come up. It looks like some of them are coming up. Let's just make this a little bit wider. Okay, the ones that are down are the ones that are going 3, 4, and 5. Let's see if we see the same thing over here. Okay, I don't see anything sourced from MPLS over here yet. Okay, so I'm looking specifically at our problem, at a problem here. C-Edge 6, but that was going over MPLS at first, so this may be a separate problem where MPLS doesn't have reachability, and I believe that is what it is. We didn't do a handoff between, so that is normal, but as long as we do have working tunnels to those sites via the other transports. So you could fix this by handing your providers off to each other in the service provider space. I'm not going to do that. I don't think it's realistic. First of all, the right answer here would be to use restrict on the MPLS tunnel interface. So just turn the restrict box on so that it doesn't try to form those tunnels to biz internet. But there's no problem with them being down. The problem that I'm seeing now is we should have tunnels sourced from MPLS on this side, and we don't. So let's do some troubleshooting. Let's start with a normal show IP route. So we can see that's there. Is that reachable though? So ping 10.254.7.1. Okay, it is. Let's go further into the MPLS topology. 10.254. Let's go to 2.2. Okay, we cannot go further into the MPLS topology. So that is our issue there. Let's take a look at our MPLS router, and let's do a show IP route. Actually, we want to do show IP route in the customer table though. So do we see 10.254.7? We do, via 10.254.6.2. So let's try to ping 10.254.7.1. Oh, that was my fault, and now we're gonna have to wait, because Control-Shift-6 doesn't pass into the browser. There we go. ping 10.254.7.1 verf A. That's what I did the first time. Oh, I typed ping again. That's my bad. Okay, so we can get down there from our MPLS. Now, the question is the CE at the data center site getting the route? It is not. It is not, because we have to advertise it into OSPF on the customer side as well here. So show run section OSPF. So we're redistributing connected. This is our underlay for IBGP reachability, and this is our PECE for the data center from the last video. That should fix our issue. So now if we go here, we should see that .7 network. Yeah, so that was why it couldn't get to vSmart. So let's take another look. Yep, so now we see those tunnels. And it's the same ones not working as the other ones, the ones that are sourced from MPLS, going to BizInternet. We don't really care about that. We can get from MPLS to MPLS. We can get from BizInternet to BizInternet. That's the important part. So now we've completed our TLOC extension. We'll test this out later in the video when we have routing beyond these, so down here, because then we'll be able to shut down this interface. Well, say this one's like the VRRP master, and it'll just go through the other C edge of that site via the TLOC extension. So that is the TLOC extension. In the next part, we're going to start working on the routing inside the sites. Now, it might seem simple. But I'm going to explain quick why it isn't. And it's one word, and it's loops. It's loops, and it's accidentally sharing one transport with another transport, and there's all these weird things that you have to worry about, because at these sites, like these two, not necessarily this one, but these two and these two, if you throw a router down beyond these, and you use the same process, the same routing protocol and the same process to peer upstream, you're gonna share those routes between transports. And then what's going to happen is you're going to have data transiting your branches to get between transports. And that's not what you want. That is not what you want at all. So we are going to do some sites where we have completely separate routing processes, and we're going to have other sites where we have to filter purposely to stop that looping. But we just have to make sure of that. So let's get that site routing done. And then we're going to jump out of Cisco Modeling Labs into VMware, and we're going to deploy DNA Center, and we're going to deploy ISE, and then we are going to get the fabric nodes configured on our topology. Okay, let's start our inter-site routing journey at the data center sites, because that's where DNA Center is going to be. That's arguably the most important. So we need to take a look at this switch right here, and I really do apologize for the fact that there's no way to change the color or routing of these links, so it just sort of looks like this and it looks terrible. But we also still have some connections to do to them, unfortunately, so we have to add. Okay, so that's more what it's going to look like, and it is very hard to see. I kind of wish I would have went with the 4-switch design from the other lab, but since we're already in vManage, let's just. Oh, we already actually did that. So, well, we have the links addressed, which is the first part, but we're going to need to run OSPF here. Now we're going to run OSPF between the C edges and the data center switch, and then we're going to run EIGRP between the DMVPN routers and data center switch. So I don't believe we've actually done like anything on this data center switch. No, that is a no. So didn't even set the host name. So SWDC1. And then we need to start looking at, let's do these first. So int G02, no switch port, IP address 172.16.11.1, and then let's grab the other one here. So this is int G03, no switch port, okay. So while we're here, we'll go int range G02 to 3, IP OSPF 1, area 0. And just because I'm gonna forget this if we don't put it anywhere, SD-WAN to core is OSPF, and then DMVPN to core is EIGRP. So that's what we're doing right now. So let's, now that we have that, and okay, so I said about separate processes earlier, I want to explain my methodology here. So we're not going to create a loop within the SD-WAN fabric itself. We more have to be careful between transports. So the reason I'm using OSPF PID1 or process ID 1 for both of these neighbors is because they're within the same transport. If we were doing OSPF between the DMVPN hubs as well, we would want to use OSPF process ID 2 or something different from the process ID that we use for the C edges, or we'd have to do some really weird filtering stuff, but then we'd need to make the DC switch in ABR, and it would be, in my opinion, more confusing than just using two separate process IDs. So let's jump back into vManage, which of course is timed out. And we'll make an OSPF template and apply it so we can see those neighborships come up. And then we'll get our DMVPN done, and then we'll start working our way around the topology to get all the other site routing done. So let's jump in here, and then we want the DCC edges. I'll start with 1, and then I'll just link the same template to 2. So let's go to our service VPN, edit, and we want to add a OSPF subtemplate, and we're going to create it, and this is going to be DC VPN 100 OSPF, and this is weird, even the OSPF, oh sorry, okay, I was gonna say, no, I did this wrong. This needs to be up here is where we want to create a template. I was gonna say, I didn't realize the OSPF template was shut down by default. Okay. Router ID we can leave as default. They all have an IPv4 address in that VPN that they can use. Do want to redistribute OMP into OSPF. So we get our routes from our branches, and then we want to make area 0, and we want to add an interface, and on both of these it is gigabit Ethernet 2. Okay. And while that updates, let's do the same thing to DC CH 2. So now we don't have to create the template, we just have to link it as a sub-template under the service VPN. I think that's why it throws me off, because it appends to the top, not to the bottom. I also noticed I spelled this host name wrong. Okay, so we just gotta wait for, oh, that's not good. Illegal reference. I wonder if we don't have the IP addresses configured like I thought we did. Let's take a look. I wonder if they both failed out, then I would be betting that's the... Doesn't look like... No, we're not showing the failure for either of them yet, so that doesn't mean much. Let's look at DC CH1. Let's edit the values. Let's take a look what we got here. Okay. Those are not supposed to be in G2. Those are supposed to be in G4. Because if we... okay. See, this is the problem when you start to reuse templates. We made it G4 for... Yeah. Okay. So, easiest way to solve this is going to 0/2. And then this is going into 0/3. Okay. Now let's reapply those templates. Actually, we need to change our OSPF template because it's still applying to G2, I believe. So that would be in here, right here. Oh, it actually applied to it dissociated itself from the device templates. That's interesting. Usually it just errors out and stays attached and it pens. So now we have to go relink it then. So let's do one first. Essentially just have to redo what we did. Yeah, it pulled it off. Okay, that's interesting behavior. Just want to make sure validation succeeds. Okay. Okay, here we go. Yeah, now we're cooking here. Okay. That was my bad. I forgot we changed our methodology that 4 was going to be the downlink on all these. Okay. So we'll soon see that other neighbor hopefully there. Now we're going to need to do DMVPN. So let's first document this. We'll make this, so that was 11 and 12, so we'll make this 13 and 14. Yep, there's that other neighbor. Okay, 13 and 14. So that's going to be there. That's going to be there. Okay. One thing we do want to make sure. Okay, we are getting our site routes from OMP. Now, here's the problem though. We are probably not getting the data center routes, but we'll troubleshoot that later once we get the template, the links to DNA and ISE in here, because then we'll be able to check. But I don't believe that the way we have the template set up that networks that we put back here are going to be propagated down. But let's get this routing working first. So let's do this side. Click on these links so I know what I'm actually working with here. So int G10, no switchboard, IP address 172.16.13.1. And then int, this is G11, Oh, no switch port. No switch port. IP address 172.16.14. This would be 1. Okay. So we're also gonna have to do this on the DMVPN side. So once again, we can run the same process here because it's within the same transport. So you'd have to really try to loop or transit through this DC core to get to other sites. So router, EIGRP, CCIE, address family, IPv4 unicast, autonomous system 100, network 172.16.13.0, and then 172.16.14.0. And then let's jump on our DMVPN routers and complete the other sides. I believe we're running EIGRP over the DMVPN already. I don't know if it's named or classic. It's classic. Okay, it doesn't matter. They interoperate fine, especially when you're only using v4. So router EIGRP1. Network 172.16.13.0. We should see that neighborship come up relatively fast if we did everything right. Okay. Oh, addressing on the link would help. Inchi01, IP address 172.16.13.2. Now we should see that come up. Come on, I just want to see it before I move on. Okay, well, I'll come back. See if it comes up. EN CompT NG01 IP address 172.16.14.2. Ah, our AS is wrong. We used 100 on the other side. Okay. We'll fix that on the other side. I'm not going to redo the entire DMVPN topology. Router EIGRP 1. Network 172.16.14. Well, let's fix that over here. Oh. There we go. Now we should also have the routes from the DMVPN network, so do show IP route. We should see some E routes in there. Oh, sorry. Some D routes in there. So this is the tunnel network. It's 172.254.254. Okay. No redistribution required on the DMVPN routers end because we're tapping into the same process that runs across the DMVPN network. So that is pretty much our inter-site route. Oh, actually, we forgot about our bare MPLS. So we need to get that set up here. So we used 14, use 15. And I believe that uses OSPF as well. So this is where that separate process ID comes in. And then we're going to want to redistribute everything into MPLS because everything's going to use the data center site to transit to get to the MPLS only router. So I'm not talking about like SD-WAN over MPLS. I'm talking about the bare MPLS router that we have down at, I believe it's 2. Yeah. So this guy, there's nothing other than MPLS, and we're expecting reachability to our private subnets, all of them, across any transport. So jump on our MPLS router. I'm just kind of curious. Okay, so router OSP. So we're running OSPF1 here. I think it's just area 0. Yeah. Okay, so int G02. And this would actually, this is going to cause an unintended design. So remember earlier we saw some of those BFD sessions down because we didn't use the restrict keyword. Those sessions are now going to come up, but they're going to transit the data center site. You're not going to want that. I mean, maybe for some reason, but you're generally not going to want that unless you're doing some type of like service insertion or something. But it's going to happen because of what we're doing here. So we would, in a real world environment, we would want to go back to our tunnel, our interface template, and change that to be restricted. So int G02 IP address 172.16.15.2. Okay, let's jump back on our DC switch. I don't even know what port that's on. G01. Okay, so I'm going to use OSPF area process ID 2 here. Should see that come up soon, and we should have all of our MPLS routes. But we're going to want to redistribute a bunch of stuff into that. So we're going to want to redistribute OSPF process ID 1 and EIGRP, EIGRP AS 1 as well. Once this comes up. So this is G01 172.16.15.1. Okay, there we go. It was just probably in wait for a long time. Okay. So router OSPF2 redistribute connected. And OSPF has a default metric, so it's just going to assign everything 20 if we don't define a metric. So redistribute EIGRP 1, redistribute. That might, oh yeah, redistribute OSPF 1. And then we need to do the exact same thing the other way. So router OSPF 1, redistribute OSPF 2. Router OSPF, router EIGRP 1, router EIG, we use name mode, EIGRP CCIE, address family, IPv4 unicast, autonomous system 100, or change it to 1, redistribute, topology base, redistribute, OSPF2 metric. This we do have to specify a metric or it's not actually going to redistribute anything. So 1000, 1000, 100, 100, 1500, enter. Now we should have all of our routes, and the one I'm specifically going to look for down here is our DMVPN tunnel network. Which I'm not seeing yet. I see all of our MPLS networks. I see this handoff is working. And I see this link. Okay. See if we see them on here. We do. So I believe I know what the problem is. Believe we have to match external. So let's take a look at the OSPF config on the service provider side, because I think that is where the problem is. It'd actually be under the BGP config. Yeah, that's our problem. Oh. There we go. Now we're seeing a much longer list of routes there. And what did I say our DMVPN network was? .172.2. Yeah, I did see that. Okay, that's right here. Okay, so this is all good. So there's these are our SD-WAN networks. We see our DMVPN networks, and we would see our data center networks as well. So that seems to be all good. So that completes the inter-site routing for the data center. That's going to be our hardest site, and it really is hard to wrap your mind around, but my theory is if you can wrap your mind around this, it's probably going to be a lot easier for you in the lab exam to wrap your mind around all the weird redistribution that might be happening there. So, I don't know what this label is doing all the way out here. We need to get a fusion, or sorry, we need to get a fusion router over here. So this is pre-planning for our SDA network. So HQ fusion for, actually HQ, we can do fusion 1. So let's connect these down to here. And actually, remember we used port 4 on these C edges. So do that. We'll do this, and we'll turn on our fusion. What this is going to do is combine our SDA virtual networks, and also it's going to act as the handoff between our border node to destinations external to the fabric. So this is going to help us out a lot in the next few videos. And then while we do that, while that's booting, we need to put in some other devices as well. So we're going to have a VIOS L2 there, a VIOS L2 here, and a VIOS L2 here. Here we're going to have a fabric in a box. So we're not really going to touch that until we get into the SDA part of the video, which is next after we get these 4 things done. So we got to remember that we used Ethernet 4 on our C edges. Let's get all these connected up. Okay, those are already going to be Ethernet 4 because it's the only port left on them. And we'll just name these here. Okay. So now we can document what we're actually going to do here. So let's get a text box here. So this is going to be OSPF with 2 process IDs so that we don't end up accidentally meshing our transports together and creating a transit site that we don't want. So I believe we have some of these networks already defined for us that we did in our templates. Let's check that out. Show IP interface brief. Yeah, okay. So we get that network, and then we'll just go up from there for over here. Okay. And on the DMVPN, we're actually going to need to address that link. I did that wrong. Okay, so we've enabled OSPF on there as well while we were there. We're going to need to attach an OSPF template to this. We can probably reuse the one from our data center, but I'm not going to. I might copy it and then reuse it. I don't want to just blindly reuse it in case we end up changing something at our data center and then having unintended effects here. I'm going to make that process ID 2 over on this side. I'll make this process ID 1 just to match that octet of the network address. We should be learning all of our destinations. Oh, well, if we did redistribution, that would help. So let's jump on here. Router 1, redistribute. PIGRP 1, redistribute, OSPF 1, metric. I don't think you have to match here. Oh, you do. Match, internal, external, metric. Okay. Should see those routes now. Yeah, so now we have reachability to the rest of the fabric, the rest of the topology through this transport. We just got to get up through this transport. So on the Fusion, we'll enable that process ID, and then we just have to go back into vManage and configure the C-Edge side of that. Okay, so what we can do is copy this one. I actually don't think we're changing anything because we're using gigabit 4 again. Yeah, we're not going to need to change anything. I just don't want them tied together like that for no reason. We just have to add it under our service VPN. And then once that, should see that come up here. It's going to be under the other process ID, but as long as we did all the interface addressing right. Yep, there we go. Okay. So now we have both of those. So now if we do a do show IP route, okay. Most of these, okay, so we're still taking the DMVPN. We also want to make sure that we're actually pulling the OMP into OSPF. We'll verify that in a second. So we need to make sure that we're actually advertising. So like if we were to shut this link down right now, we would only get the SD-WAN routes from the C-Edge side, and the reason is our advertise statements on the templates for these two C-Edges. So if we look in the templates for our data center C-Edge, okay, I actually think we could get to it faster here. So we have connected selected, but we are running OSPF. Shouldn't need anything else at this point. And now, like I said, this is one of those spots where we have this unnecessarily tied to a bunch of different templates, and we're going to be making this change on devices that may not necessarily need it right now. So we just want to be aware of that. So yeah, 8 devices, all 8 of our C-Edges, even though we're only trying to target this part of the topology up here. Okay, so let's go through the rest of our sites now, and we will do essentially the same thing. Let's grab one of these labels here. Wish you could scroll while grabbing a label. Okay. So this is, I believe, site 101. So let's just get these all labeled first. So 101.1 and 101.2. 10. Oh, I did 101.2. And then let's jump over here. Let's make this a little bigger. Let's be 102.1, 102.2, 103.1, 103.2. And then 104 doesn't have anything yet, but we'll make the label a while and throw it over there for when we put the fabric in a box over there. So our C-Edge should already have the addressing. It won't have the routing, but it'll have the addressing. So we're going to do the same thing we did at the data center site here. We're going to use OSPF with 2 process IDs. So let's jump in here. Oh, well, we'll do something else while that time's out. We'll do the DMVPN router. Int G01, IP address 10.101.2.1. Okay. That's still going. So we are going to need to add an OSPF template over here as well. And I'm going to copy this and throw it down there as well, just so we know what's going on with this site. Okay, so that's IP OSPF 2 area 0, just so we don't have automatic redistribution between the two, because we don't want that. Okay, that was our DMVPN router, so we're going to have to apply a template to the C-Edge before we get that to work. But before we do that, I'm going to go router OSPF 1 redistribute connected, router OSPF 2 redistribute connected, int loopback 0, IP address 10. We can actually do, let's just do 10, 10, 10, 10, and then we'll do 20, 20, 20, 20, 30, 30, 30, 30. So we should already be able to see that on other sites throughout the DMVPN. Actually, no, we need to do some redistribution here. So router do show run section router. And this is going to need to be match internal, external, metric, I believe you can use 100 for all of these and it would just work fine. And then we need your router OSPF 1 redistribute EIGRP. What was our process number? 1. Now we should be able to see that 10, 10, 10, 10 up on our DC, all the way up on our DC core, if we did all of our routing right. We only have one path to it right now, but yeah, so here it is. Well, we see 2 paths because we have 2 hubs, but in reality, we should be seeing paths through the SD-WAN network as well that we're not seeing yet because we need to attach that template. So let's do just that. So let's take a look. This is C-Edge 4. But actually, to be faster, let's just copy our HQ VPN 100 template and we'll make it BR1 OSPF. Oh, hit view. Jump down to the service VPN, edit, add in the OSPF, and click the one we just made. And this is still on Gigabit Ethernet 4, so there should be no modification required to that template. We should just see another OSPF neighbor on this box pretty soon. While we're working on that, the next site over, we're going to use BGP. And what I think I'm going to try to do is use iBGP here, here, and here. That way, natively, we won't make this a route reflector, so that way, when we receive routes from the MPLS domain, we won't send them to C-Edge 5. So as long as we can keep the AS numbers the same, the loop prevention will be done for us. So let's do this. iBGP. Yes. What branch is this? Or what site ID rather? This is 102. So we'll do iBGP AS 102. Okay, so we got those sides addressed. This should already be addressed. We got to address that, but we're going to have to do a BGP config before we do that. Okay, so let's get a BGP config quickly written out for the branch 2 switch. And then likewise we want to do this for the DMVPN router. Okay. So this is for the branch 2 switch. Oh, swapped the wrong number there, sorry. That is for the branch 2 switch. This is for, I said DMVPN, I meant MPLS. And I'm wondering if we ran BGP here. And we did, and that's going to be a problem. Because we obviously can't. Well, we can set the local AS. We might still be able to do this. For some reason I was thinking that was DMVPN. So let's go into here. Let's still define this neighbor. And then let's set the local AS. It's either a local AS or I believe it's local AS. Let's look this up. This might do what we want it to do. See in a second. I do have to do the IP address configuration on here still, I believe. So NG01 IP address 10.102.1. Okay, that did do what we wanted to do. Whether it's going to have the loop prevention efforts we want, I don't know yet. I'm trying to think of how the spec works. Obviously, the branch 2 switch has no choice but to think of it as an IBGP. Oh, no. It does know the difference, it would seem. Oh, sorry. No. We're on the wrong box here. Okay, I was going to say the branch 2 switch has no way to know it's in another AS, but the MPLS2 router does. So it shouldn't matter though, because the branch 2 switch should still give the loop prevention effect that we want. So now we have that routing done here. We have to make a BGP template in vManage for CH5. So let's just hop onto that device template. We'll do it in one swoop here. Let's go under the service VPN and we'll add a Cisco BGP template. Create a new one. CE5 BGP. The AS number will make 102. And new redistribute, we want to send OMP into the protocol. And then we need to define our neighbor. So this would be 10.102.1.2. And the remote AS is 102. And we want to turn address families on, and we want to select IPv4 unicast. And there's another change I want to make as well. This is actually going to change more than you want it to change. It changes a lot of stuff about OMP, which is really, really weird, and I almost wish it wouldn't because it confused me at first. But it shouldn't really affect anything. It might bounce the vSmart session. Let's take a look at what else I want to show you. So now we have to think about getting those routes back into OMP that we learned from BGP. So we are going to have to change that, and this is that template that applies everywhere, so just be careful. Luckily this is the only place this would actually have an effect. But okay, there was our adjacency change. Our neighbor did come up. So let's test our loop prevention theories. So we're receiving 23 prefixes from the MPLS router and 0 prefixes from the C edge. So that is a little weird. Let's take a look at our BGP template again. Okay, so we're redistributing OMP in. Okay, it was just a timing thing. It's probably because of all those weird changes vManage makes. So now what we want to check though, so let's make loopback 0. So now what we want to make sure is if we do our verification commands on here, we're only receiving 1 prefix. So, yep, we're only receiving 1 prefix, so we're not receiving prefixes from this transport and sending them back out this one. Let's just make sure that's the same case the other way. Oh, one too many enters. Okay, this is actually a really good tip, and this is something that I didn't know, which is why I was struggling with show commands for a second. If you're using BGP on a C edge, even on the service side, you need to act like you're using MPLS VPN v4 because of the way the VRF is under the BGP process. So here we can see, though, our loop prevention did work. We're only receiving the loopback address and advertising that out through the transport. So now this site is complete. So now we have routing over here, we have routing over here, and we have routing over here. So now we have one more site to do, and that is this site over here, branch 3. Okay, so time for our last site of this part of the video before we move on to our DNA Center and ISE deployment, and then subsequently SD access. We need to get this one last site done. This last site's going to be a little bit different, and I realized that I made an error in labeling here. We're actually not going to need this second network because we're going to be doing VRRP. This switch is literally going to be a layer 2 switch with a interface in VLAN 1. So we're going to need to make a VRRP template and apply it to C Edge 6 and 7, and we're also going to need to change something about C Edge 7. So let's click on here and click Change Device Values, which allows us to edit those variables in our templates after the fact. So it just basically brings us back to this screen, and we are going to change our Gigabit Ethernet 4 IP address. We're going to make that, wherever that is, should be 10.103.1. We're going to make this, we'll make it 7, and then we'll make the other one 6. So we just did that, so let's go back here, and we're going to go to CH6, and we're going to change the device values, and we are going to make this one 6. Okay, so now we need to make a VRRP template and apply it. So let's go to templates, we'll go to device templates, and we'll start on CH6 again, hit edit. Actually, I think this might be under the service VPN. Let me just make sure. It is under the Ethernet VPN template. So we'll need to copy this global interface, and we'll put a -VRRP on the end, because we are going to turn on VRRP with a group ID of 103 and an IP address of 10.103.1.1. And this is why we had to make sure no router individually had 10.103.1.1, because we needed to make the VRRP virtual IP 10.103.1.1. Now we just need to actually swap that out. So let's go to CE6, and then we're going to need to do the same thing for CE7, and we just need to swap that template out. There should be no variable changes required here. Okay, so now let's jump down on our switch. It's going to be a little different. We're not going to do a loop back here. We're just going to do change the VLAN1 interface. And then we'll put in a default route to our VRRP gateway. So let's just make sure we can hit 10.103.1.6. Interestingly enough, we cannot. Let's try 1.7. Okay, well that's quite interesting. Let's just make sure. Ah, that's why. Sometimes on Cisco switches, the SVIs take a little bit to come up if you don't manually no-shut them. So we can get to 6. We can get to, oh, I spoke a little bit too soon. Let's see if I lied. Nope, we can get to 7. And we can get to our VRRP address. So now if we needed to go further into the network, like, oh, let's try one of those loopbacks we created. Yep, there we go. So now we have reachability from what is our simulated end host, which is the loopback on these switches, at each site to every other site. C-Edge 8 is there. It has an IP, but because we're doing Fabric in a Box, we're going to wait. We're also going to have a Fabric site over here. So up here and down here are going to be our 2 Fabric sites. This being a full-blown Fabric site with multiple edges and a dedicated border and control plane node and the bottom one is just going to be a single Catalyst 9000V fabric box. So I'm going to cut here. We will work on getting DNA Center stood up in ESXi, and then bridging it into the topology. We'll do the same thing with ISE, and then we'll come back into modeling labs and we'll get our Catalyst 9000Vs deployed. Okay guys, so I'm back again. It's the next day and we're going to get all of our DNA Center and ISE stuff and our Catalyst 9kV stuff out of the way now. I'm going to start by referencing that PowerPoint that I showed at the first part of the video, so this one, because we essentially have to do this bottom half here. So it's not in order the way that you do it, so we're going to have to create the VLAN on our underlay. We're going to have to create the VMware port group. We're going to have to create the bridge in CML, or the bridge in Cockpit on CML, and then the connector inside of the CML web UI, and then we can spin up our DNA Center. So let's start, and this is the part that's sort of going to be different for everybody because it's highly dependent on how your underlay works. But let's try to get into my switch. I think it's, yeah. Okay. So I have a sort of, so we don't spend time thinking about it, I made this subnet, which is going to be my network that's extended outside of CML and over to DNAC. So let's just make that VLAN 1291, name DNAC ISE YouTube. And that's all we should have to do here. We don't really need to put an SVI or anything in it because it's not going to route anywhere except for within our topology. So that's pretty much all we need to do on the underlay. So now we've pretty much done this portion because this is already a trunk port and this is already a trunk port. So we shouldn't need to do anything special there. I'm going to do my next part in vCenter. If you guys don't have vCenter, it's pretty much identical in ESXi. I'll probably, if I ever do this series again, I'm probably not going to use VMware at all, just because of all the Broadcom stuff. And now that there's nobody to get ESXi for free and you pretty much have to buy vMug, you really shouldn't have to pay Broadcom to lab for your CCIE. So I'm thinking about redoing this in something like Proxmox or XCPNG or something more open. But this is what I have for now. I'm sure these steps pretty much translate to other hypervisors as well. So let's start to, so this is the host my CML is on, and this is the host my DNAC is on. So we're gonna need to do this on both. So let's go to my virtual switches, and this is the virtual switch. So we need to add, actually, what number is that? So okay, I see that. So we want to add a virtual machine port group for a standard switch, this switch, and then we'll call this YouTube DNAC ISE. And the VLAN, what did I say that's going to be? It's down here somewhere, 1291. Okay, and because I'm violently against distributed switching, we're going to need to add it again down here. Okay, so now we have the port group. So now if we go back to our PowerPoint, we've created this and we've created this. The next logical thing is to create this. Before we do that, we're going to need to create the interface on the CML host. So let's edit our settings, and I kind of forget if we're going to need to reboot CML to do this. I'll spare you the time if we do need to do that, because I'm going to have to shut down our lab. Let's just see what we have now. So this interface, if you're not familiar, this is called Cockpit. It comes with CML by default. It's running on port 9090. The default username is sysadmin, SYSADMIN, and the password is whatever you set in the CML installation wizard. So we're specifically interested in host and then networking, because this is where you define the bridges that you can bridge into your topology. So what I'm looking for, Okay. Because if we hit add bridge now, we're going to have to figure out what's not here. And I mean, the easy way to do that is to look at the MAC address, because we're going to need to add a new network adapter and then select. Okay. Oh, and we actually saw that change over here, this ENS 256. If we click on that, and then we click on edit settings, and we look at this, this ends in FE77, and this ends in FE77. So the answer is no, you don't need to reboot. So we are now going to add a bridge, and we'll call this, I'm going to leave it bridge 3 just because I've been going in order. And we're going to want to bridge in that ENS 256 interface. So now ENS 256 went away. There's something that I changed here. I changed the IPv4 settings on the bridge itself. The reason is it's going to sit here and try to get a DHCP address forever. And I've seen, for some reason, it will turn the bridge off when it fails DHCP a certain amount of times. That's just what I've experienced. And to fix that, you can just change this to link local, which just gives it in a PIPA and just pins the interface up. And I've found that that works a little bit more reliably. See, now it's not stuck at configuring IP anymore. You could also give it a valid IP. I mean, there's no benefit to that, though. So I've found that just changing that a little bit helps a lot. I'm going to refresh this just so we have the most recent data. And then what we should be able to do is add an external connector up at our data center site. Right there. We'll name this DNA C ISE, and then under config, we're gonna want bridge 3. Now this seems to be where the problem arises. You can see we can't see bridge 3 in here, and I'm pretty sure that's because we're gonna have to restart the CML controller service, and at that point you might as well just restart the entire CML virtual machine, because we do have the NIC and it is connected, and we do have, you know, the bridge in cockpit, and it is up, it's receiving traffic. So in this case, it looks like we are going to have to reboot CML. While I do that, I will pause the video and I will jump back when I have CML back up and running with that new bridge populated. Okay, apparently I am a liar. So I rebooted again because I was really doubting myself, because I swear I've done this before without rebooting. So I went to system administration, and then I went to external connectors, and I could see it here. So then I went back to our lab, and I clicked on this again, and now you can see it here. So now we can uplink that to our core switch. So now what we've done is we built the connector linked back to the bridge that we made in cockpit. The bridge links back to the VMware port group, which we made over here, and then the port group is trunked down to our underlay. And then we have a VMware port group on the other host where our DNAC is going to reside. Let's make sure this turns on. I have seen some instances where if you configure the bridge wrong, it'll just turn on and turn back off, and this will stay dotted. But it looks like we've done everything right. The next thing we're going to do is install DNA Center. Now, I'm going to install DNA Center on a new data store that I just made for this video. Just because I have another DNA Center that I don't want to delete because I do use it for other stuff. So I threw some more SSDs in my servers over there so we can do this video. So let's make a new virtual machine. Unfortunately, I don't have the OVA or OVF template for DNA Center that I heard does exist somewhere inside of Cisco. I do have the ISO, so that's what we're going to use. So we'll call this YT-DNAC. We'll put it on UCS2. And we'll put it on the data store that I made for DNA Center. That'll be fine. I don't have any hosts less than that. I believe I use other Linux 64. There's some stuff with NICs. So the DNA Center, whatever it's built on, I guess maglev, it doesn't have drivers for certain NICs in VMware. So if you have trouble where traffic's being black holed while it's exiting your DNAC and dropping onto the virtual wire, I would check that. It seems like selecting other Linux 64 in this part of the wizard puts the right type of NIC in though, so I usually just leave it like that. So obviously our specs are wildly off here. We need 40 CPU cores. We need 150 gigabytes of memory. And we need 600 gigs of hard disk space. And then we need at least 2 NICs, so we're going to add another network adapter. The first network adapter we will put into our network that we made. The second network adapter I'm going to put into a network that, that my workstation can get to so that we can access the web interface from outside. Okay, so one thing I did forget to do that I just realized is actually mount the ISO. So let's change this to data store ISO file and then hunt around for it here. Kind of forget. It's on one of these. It's a very big file, so it's right here. So the version we want is 2355. That is, to my knowledge, the first version that allows you to use Catalyst 9000 Vs of any type. If you try, because I tried with 2337 at one point, just don't even try. False hope, you get so far, and then when you try to add it to the Fabric site, it'll say that you're missing the IP routing command even though you're not. So it looks like there's some incomplete device packs there in the previous versions. Connect it, power on, and then we will right click this, power on, and it's, oh, so that means that I do not have, it's a very weird error, but what the error means is that I don't have enough disk space to create the page file, which means 600 plus 150 is greater than my disk space. So let's see how much disk space I actually have. 745, so I was 5 gigs off. It is very strict with that. Because essentially when you boot a VM in VMware, it makes a page file equivalent to the amount of RAM you give the system, and when you're dealing with a RAM this high, you start having issues. So let's delete the device and data, add a new hard disk, and instead of, we'll make it, we can make it 550 gigs, and that should, because this is 5, 6, it's 700 gigs, we definitely have. Okay, we have to, order of operations thing here. We have to delete that other one from disk first, reconfigure again, add a new hard disk, and make it 550 gigs. It does not see that that other one is deleted from disk yet. Oh, now it does. We might have moved too fast. Yeah, now it does. So you can see the maximum size is 743. It thinks that, but once you subtract the amount of RAM the host has from that, you're not going to get that much, and that's what we were just experiencing. Okay, no monitor loop this time, so that's good. So in Cisco DNA Center installer. This is going to take a little bit, and honestly there's not much interactive stuff here, so I'm going to pause the video until we get to the installation wizard. Okay, so we booted up to this screen, and we can see we got a valid IP on my network on the other side, so on my network on the non-fabric side, the management side. So now we know that at least that side is working. So we're going to start a DNA Center cluster in IPv4 mode. We don't need to do, we're not doing anything like layer 2 bonds or anything. So, okay, so this is a little weird how you have to figure out which NICs are which. So it's going to say the wizard detected that there are 2 network adapters. So the enterprise network we're going to use as the network facing the fabric. So this is also going to be the network with our default gateway on it. So let's put in an IP address here that's in our subnet that we derived down here. So we'll do 172 And we're not going to want to proceed with this quite yet because you're going to actually need the DNS, well, not the DNS servers necessarily, I don't know, but the gateway, I do know for sure has to be reachable. I think the DNS server still lets you skip. So before we even do this, we need to jump on our data center switch and go to G12 where our cloud is connected, and no switch port, and IP address 172.16.129.1. So now our default gateway is reachable, and we can make that a DNS server too, but it doesn't really matter. Apparently it doesn't like that. Okay, so the static routes we don't need because this side has our default gateway on it, and this is network adapter 2, which is the cluster interface. We must select a cluster link, I believe, so this will be our cluster link. We'll give it an IP address 10.3.1.2.5.2. And we won't give this side a default gateway. DNS servers we can set on this side if we wanted to. Let me figure out what the DNS server is actually going to be. So this is the DNS server that I use for my CCIE Labs. It's also a domain controller and a certificate authority. So it's 10.3.1.102. So we can just fill that in a while. No static routes here as well. And then hit proceed. This is going to take some time, so I'll stop the recording and come back. So we're going to be presented with a screen that basically says, I can't connect to the internet, give me a proxy. The trick here is to just hit next. And we're not building a cluster, so we don't need a cluster, host name or IP. So this is where we're going to set all of our passwords. If you're not using the auto-generated password, you don't need to give it a seed. It will make you put in an NTP server. So I actually put an NTP server on this box. So I guess I should tell you the story about this box and why it exists. So if we go back, this box is this, which I did say I did recommend having if you're going to build this lab, because you need a DNS server, you need an NTP server, and yeah, you could use public resources for this, but you should have this anyway, because when we go to do host onboarding in ISE, it's nice to have a CA for your clients if you want to do EAP testing and stuff. I mean, I don't know how deep you're going to get into that, but if you are going to use external ID stores in ISE and you are going to try testing EAP TLS and stuff, it's just a given that you have Windows Server. Also, it makes a very nice DHCP server for when you're testing out Fabric DHCP, and it's compliant with, I believe it's option 82, which SDA DHCP needs to have to trace back what VN it came from. So I would recommend having at least one Windows Server box in your lab. Just for those reasons, it just makes it a lot easier. And this sometimes takes a while too, so I'll be back. Now we're presented with a screen that basically says the container, we need to define a container subnet. I wouldn't change this. If you're familiar with how DNA Center works, it's literally like microservice hell. Like there's like 120 some containers on the back end, which is why that container subnet's so large. And that is also why DNA takes so much resources. It's why DNA takes a long time to start, and it's why DNA will crash in portions. So like the assurance portion will crash, or the policy portion will crash. So this is essentially the network that runs inside of DNAC to allow communication between all of those microservices. As long as you're not using it anywhere else in your topology, you can put anything here. I just leave it the default because I think that's actually a pipa space, so that you wouldn't be using it anywhere else in your lab. And then this is basically saying you're ready to apply the configuration. I believe this is the last step. If it is the last step, I won't be back until DNAC is booted, which will probably take about 3 or 4 hours. If anything pops up in the interim, I'll be sure to record it just so you know to expect it. And if this is the last step, I may come back and start doing the Catalyst 9kV deployments and bootstrapping just so those are ready, because I'm trying to get this video out today. So I sort of have to interweave stuff inside of DNA Center installing. So I'll be back. Okay, so while DNA Center installs, let's actually get ISE going quick. So ISE is a little different because it comes as an OVA. So it's basically a template that includes not only the installed ISE disk, but some metadata that allows the VM specs to be set up for you, which is nice. You could also use the ISO and install it just like we did DNAC, but I wouldn't, because there's just more steps for you to do and more for us to mess up instead of just manually doing this. So let's find this. Yay. Okay, so we're going to want ISE 3.3. The reason I'm using 3.3 is because it's the first version after the little UI redesign they did. And I don't want this video to immediately be aged. So we'll use 3.3. There's really no difference except the side menu, and there's some new cool TrustSec Meraki integration stuff. This is going to take a while, by the way, because this is like a 14.2 gig OVA, it looks like. And it needs to be uploaded from wherever you select to the ESXi server while DNA Center, in our case, is installing on the same server. So yeah, 13.6. It's going to create a 300 gig disk. We are going to use the eval size, and we are going to use the ISE data store that we made, and we're going to put it on the same network that the DNA Center is on. And like I said, it will configure everything else for you. There's no need to really touch anything else. You just hit finish and then make sure you don't navigate off this page for a while this uploads. Okay, so let's get our Catalyst 9000 Vs and our Catalyst 8k Vs that we're going to use for our border and our edge and our fabric in a box. Let's get those all into the topology. So let's start with our border. So this is going to be Catalyst 8000V, wherever that is. See how many interfaces this has. We'll just add just to be safe. And we will name this HQ SDA border control plane. So this is going to be our border and our control plane node for the headquarters site. The uplink is going to go to our Fusion router, which is going to break out our VNs. And then the downlink is going to go to the Catalyst 9000V. Now, before we drag that onto the screen, we need to do something. We need to, if you are manually randomizing your serial numbers, you need to actually randomize the serial number. So I took it off of here. It looks like in this version. But if you had a serial number line under this, you would need to manually change that. Let's get back down here. So let's add it. Like I said, the Catalyst 9000V that comes with CML will not work for this. There's no DNA device pack for that model of the data plane virtualization. So HQ SDA edge. Actually, we may add another one of these in the future, the physical edges that I have. So you also don't want to use the management port as your uplink because it's in the management VRF. So you sort of want to do something like that. We'll start our border control plane node first, and I'm going to let that boot before I even try to start the SDA edge node because they're very large. And I'm just going to draw a box around our fabric site here. And then we will copy this box down here where we place our second edge node, and this is going to be, or our second, this is going to be fabric in a box, so BR4 FIAB. And a fabric in a box is just an SDA node that possesses all three major SDA roles. So that's border to connect to external networks, that is control plane to be the Lisp map server and map resolver, and that is edge node to connect access ports to and run the endpoints of the Lisp tunnels. Once again, we don't want to use that management interface on the Catalyst 9000V as our uplink because we would end up having to switch that later. Okay, so now our two fabric sites are in. They're in red. I guess we should change this to something else. Okay, SD-WAN controllers are now in blue and fabric sites are in red. And we will, just for clarity, make this red as well. Okay, so now our SD-WAN controllers are in blue and all of our fabric related stuff is in red. Let's see how far along our border node is. Okay, it is still booting. I think we are safe to get the SDA edge node started. Okay, so this is why I was sort of tripped up when I realized I had the serial number randomization enabled, because I selected the wrong node definition. This is actually the one I used, the data Doppler, or whatever that is, the DD control plane, and I just have a custom image definition from the one that they gave us. So I already dragged this one on, so I'll just let this use the default serial number. This should start now. It usually takes a bit because I think these use 24 gigs of RAM each. So just something to, every one of those you drag on, you are using 24 gigs of RAM. And don't even try to lower it, because if you lower it, it will literally just not get past like the bootloader. It'll say that it fails to decompress. So actually, hold on, let me delete this. And then I'm going to change my serial number. So that's the DD, and we're going to go down to the serial number, and we're going to make this serial number my SDA serial 002. Click update, and now when we drag one onto the screen, it will use that serial, and it won't go back and change anything like preemptively. So the one that we already drug onto the screen will have the serial number that it has forever. We have to make sure we switch this to, and this image that I'm using is from Terry Vinson. If you look in his YouTube comments, he has some stuff about how to get it. I don't know that it's anywhere else. Let's try to get this one booting. Sometimes if you boot them two at a time, they get a little antsy. I think it's because of how much like CPU and RAM they take to boot. Let's check on our border. Okay, it looks like our border is booted, so that's good. I'm just trying to like babysit this and make sure that this actually starts to boot. Okay, we can start on our border. Let's define some networks here. So this here is still going to be outside of our fabric, this link. And we are going to need to run a dynamic routing protocol between the border control plane and the fusion router, because, and redistribute that protocol into our transports, because our DNA Center and ISE need to be able to get to the loopbacks that are on our SDA nodes. Because ISE DNA Center is going to configure the edge nodes to use loopback 0 as a radius source interface, and also when we go to register with our control plane nodes, we're going to register all the endpoints behind ourselves as an edge node. We're going to register those with our RLOC as the router locator as our loopback address. So that loopback needs to be routable. And we're going to achieve that with some dynamic routing between these two. So let's actually jump on. We'll get this fusion router. So let's see what we're doing here. It's only been a day and I already sort of forget what we've been doing. Okay, so we have 2 PIDs, so we'll make a third. So int g02 IP address 10.110.3.1, and we will say IP OSPF 3 area 0 no shut. Now we need to do some redistribution. So we need to go into router OSPF 3, redistribute OSPF 1 match in and X. And then we need to do that same thing a few more times. So we need to also pull our other transport in. This is the downside of using multiple process IDs for loop prevention, by the way. Router OSPF 2, and we want to redistribute OSPF 3, and then router OSPF 1, redistribute OSPF 3. Okay. Now let's go to our border control plane. HQ SDA BCP int G1 IP address 10.110.3.2 IP OSPF, and the PIDs obviously don't have to match, so IP OSPF 1 area 0 no shut. While we wait for, we're probably in the OSPF wait state right now. While we are there, first of all, this is bothering me, so let's change the layer on this. Okay, and then we'll clone it. Okay, there was our neighbor ship. Now everything in an SDA fabric needs to have a loopback address. And needs to be reachable, because like I said, that is how the inner workings of Lisp work. So these can be /32s, these should be /32s. And we need to run our IGP on them. So that's why we redistributed back into our transports. And we need to be able to see that over here, because when ISE is logically sitting behind here, ISE needs to be able to route back. So let's look at our routing table. We should have all of our routes. Now what we don't have is the DNA Center route, and that is my own doing here. So we want to see show run section router to see what protocols, oh, I spelled router right though, to see what protocols we are running. I kind of forget. Oh, OSPF and EIGRP, probably a few different processes. Yes. Okay. So we need some network statements, or we need to redistribute. So OSPF 2 is probably already getting this. Let's go into here. So this is going to advertise it to our DMVPN. We should have put a, here, let me, sorry I'm a little all over the place. Let's get this documented, 172.16.129. And then we need to do the same thing in OSPF 1 and OSPF 2. Actually, we're already redistributing connected here. Let's just redistribute connected in OSPF 1. Let's go back to our border control plane node. There we go. I don't actually know if we can ping DNA Center yet. I don't know what state that's in. I would guess not in the current state. So let's just try to ping its gateway and assume that if there's a problem past that, it's not our fault over here. So let's ping 172.16.129.1 and source it from loopback 0. Oh, I made a typo here, sorry. 128 is the DNA Center network in my other lab. So I kind of went against what my mouth was saying there. Okay, so we are good. We are good up to this point. Now that OSPF process, we're going to want to extend down to our edge node once it boots. But before we even do that, there's some Bootstrap that you need to do. Let me get another notepad window here. There's some Bootstrap that you need to do for DNA Center to work. So first of all, we're just going to write this Bootstrap out here. So we're going to want to set the host name. We're also going to want to make loopback 0, which we already did on this box, but we need SNMP enabled. For read and read write. Okay. We also need an IP domain name set to generate our crypto keys. So IP domain name CCIE.local. And then we want to generate our keys. So crypto RSA generate. I think it's actually crypto key generate RSA mod 2048 IP SSH version 2. And then we also need netconf yang. So that will, and I'll show you all this later when we're inside a DNA Center, why we need to do all this. We also need to make our user, so username DNA, priv 15 password ISE is cool, and a new model. I'm typing something wrong here. It's off the top of my head. We'll catch it when we paste it back in. And then we need AAA authentication. This is where I blank out a little bit. We might have to do that. Okay, so AAA authentication. I think it's console default local. AAA authorization. And this authorization command is needed for netconf to work. Might be, we'll have to get those off the CLI. And then line VTY 04. I don't like to write things down before the videos because, you know, the videos give something to me too, and that I have to remember all this stuff. So I really don't like to write things down and then look at it. I mean, all that I really keep on my other monitor is like OBS and sometimes like a Cisco config guide. So exec timeout. I think it's actually, it might be a dash. Here, let's just do this on the router. So we've already done, well, we didn't do this. Let's paste that in. So we got that far. AAA authentication. Is it console? Is it local? Login. Sorry. Login. Default. Local. Something looked wrong there. And then AAA authorization. There's one that you needed is exec. And that needs to be set to local as well. And that, if you don't do that, I believe it will cause netconf yang to fail. So we need to generate our RSA keys, which sometimes thought we did that up here. Okay. There we go. That should allow us to turn on SSH, which should allow us to turn on netconf. We already did a loop back here, so we don't need to do that again. SNMP needs to be turned on. Didn't like something there, but I can't see because of all the garbage. Oh, okay. Needs to be an O here. Okay. And then under the console line, we need to log in local transport input SSH and priv 15. And there's another one, it's like exec, that I like to do. It's so nice to have. I think it's exec timeout 0. Let's take a look. Okay. I think you need an I here. Yeah, I remember that. Okay. So it doesn't like the login local because we are using AAA new model. So you have to do login authentication default. Okay, this is our complete Bootstrap. So this is, in my opinion, the minimum required for you to get DNA Center to talk to your devices. So this is before you add them to inventory. This is essentially what PNP would do for you with like a LAN automation or something like that. And to test this, just because I don't want to lock myself out, let's try to SSH in. Okay, I knew it was something weird. It's -L. Okay, there we go. So now we're in. So we know that we're not going to lock ourselves out. It's incredibly slow, but we're in. Okay, so that means that our border control plane is bootstrapped. Let's see if our edge is ready to be bootstrapped. It is. Okay, and it was trying to do PNP. I might do a video on PNP where we try to do some PNP stuff. I might have to break out the physical edge nodes and the physical border control plane nodes in the lab, but I'll try it with this stuff too. Don't think it's possible, but we'll see. So let's get this ready for SDA Edge 1. So one thing we're going to need to change most definitely is the loopback 0 IP address, 10.110.254.2, and we're also going to need to define its uplink. So in 101 and IP address 10.110.254, actually sorry, 10.110.4.2. And this needs to be no switch ported. And we need to make sure also that IP routing is enabled. I believe it already is on the 9kV, but this should be good. We do need to go back to our border control plane node and configure the downstream interface. So in G2, IP address 10.110.250, sorry, I keep reading the wrong label, 4.1. To prevent myself from doing that, I should just label the lab properly, if it allows me to. It is not. Let me quick... Ah, my trust of the cert timed out. Okay. Let's grab this, clone it, put it over here, change it to 4, and we're all good. Okay, let's jump back on our edge node, console in, and we got to fill out the host name too. So HQ SDA E1. And there also is some licensing stuff that we need to do on these two. We'll do that. We have to wait for them to reload while we do it. So while those are reloading, we'll do our FIAB, and then we'll be done with the bootstrapping. I believe we're good. If we're not good, we will look back through and figure it out. Let's just sanity check. Let's look back. I know we checked it all individually. So this took. Just a warning. That took. All this stuff took. All that took. And our OSPF adjacency is up. One way we can verify all of this is to ping DNA Center, so 172.16.129 with a gateway for DNA Center, and source it from loopback 0. And we can get there. So that's going through a border control plane node, out our fusion, over one of these transports, in through that transport, and stopping right here. So that ping was to right here. So that means when DNA Center tries to add that device, whether we add it via its upstream address or we add it via its loopback, it will succeed. So let's write config, and then let's look at the licensing. So do show ver. It's probably not satisfactory for what we need here. Yeah, so let's exit. I think it might be in config mode, I think. So it's license, boot, level, network advantage, add-on DNA advantage. And I'm just going to copy this because this is the exact same thing we're going to need on our border and control plane node. And then we just need to reload. So that's going to reload. While that's reloading, let's issue that same command on our border control plane node. Write it and reload it. Believe we would have issues with, we would be able to get them into DNA Center, but I believe we'd have issues adding them to a Fabric site without upping the license level. So now that's all done. This looks like it's stuck. This is my surprise face that is stuck. So let's try that again. Okay, and finally, after wrestling with it for a while and CML is still complaining, I have all of the nodes started. I am very, very much pushing the memory limit here. The weird thing is I actually do have more RAM I could give it, but the page file would be too big. I don't have the SSD space. I have a disk shelf that I got. It's in the rack. I need to source some hardware for a TrueNAS box to sit in between my VMware environment and that disk shelf. And then we should be able to do some bigger labs without these issues. But everything is booted now, so we just have to bootstrap the Fabric in a box. This is going to be a little different because right here, so let's just get another box on the screen. Because this is a really important concept, and I feel like a lot of people, especially from a design perspective, don't understand this part of it here. So what we're doing now is we're configuring the infra VN, or the global routing table. So we're giving the Fabric in a box reachability via the global routing table back to DNA Center. But we will also have the ability to give other VNs the ability to talk out onto the SD-WAN fabric. So in this instance, the C-Edge is sort of like our Fusion device, because we're going to have sub-interfaces up here, and we're going to have sub-interfaces down here, and we're going to peer BGP when we do our transport out to the SD-WAN from the SDA fabric. So people call this an NNI, or network to network interface. So that's pretty much, let me get a better color on here. That's pretty much what this is. This is an NNI between our SDA and our SD-WAN. And Cisco actually used to have a different way to do this. They would have a, it was called an SD-WAN transit. This is now the new version of the SD-WAN transit, because The old version used an API integration between vManage and DNA Center, and that version is now so frowned upon that Cisco will actually, you can put in an attack case and they will help you reverse it if you did that integration. Apparently there was some very tight version coupling between vManage and DNA Center, and they want to get away from that. So the new way is a little bit more manual. Apparently they have some workflows built out to automate it externally from the controllers, but essentially what's going to happen is the global routing table is going to be on the native VLAN, and then all of our VNs, so like if we had on our SD-WAN we created a Corp 100 on the SD-WAN side, that would map over to a VN 100 on the SDA side, and that could be like G2.100 maps to G10.100. They both in-cap with just a .1Q tag of 100, and then they run BGP over that. So you essentially have one BGP session per VRF. It's not like, don't think VPN v4, because it's not one BGP session carrying routes from multiple VRFs. It's a VRF light handoff. It's a labelless handoff. There's no VPN v4. It's just you have VRFs on one side, you have VRFs on the other, you have sub-interfaces on one side, you have sub-interfaces on the other. Think of them, if it helps, as separate cables. Every separate Ethernet cables. Every SD-WAN VPN and every SDA VN have a separate cable between the FIAB and the C edge. All we're doing is co-locating that onto one link using .1Q tags. And there's a separate BGP session for each VN. So now that we know that, we can get our FIAB bootstrapped. We're also going to need to jump into vManage because we have this configured, but we're going to need to, I believe, not right now, but we will need to add, well, yes, right now, we'll need to add a BGP template because we need to get underlay reachability, or we could use OSPF. So I think that's what we're going to do because I think it's a little bit simpler to see. So the global routing table for the native VLAN, we can use OSPF for loopback reachability. And then for all of these will have to use BGP because they will be controlled by the DNA Center user interface when we create our transits. Because this is now just a normal IP transit. There's no such thing as on the technical side as an SD-WAN transit anymore. It is called an SD-WAN transit in marketing material and in like Cisco Live presentations, but what they really mean is an IP transit to a C edge. There are only two types of transits now on the technical side. There is an IP transit and there is an SDA transit. And an SDA transit uses a transit control plane node, and that's a little bit more advanced, too advanced for this video anyway. So just know there's two, from the technical side, there's two types. Now, there's IP transit, which is what we're using at both sites, because here we're doing VRF light between the border control plane and the fusion, and here we're doing VRF light between an FIAB and a C edge, but the C edge is acting as our fusion and meshing those VRFs together if we wanted it to. So we'll use OSPF, which means we will need to jump into vManage now. But let's get this FIAB bootstrap first. So this is BR4-FIAB. We don't need to change anything up here. We need to change this to 104.1. We need to change this to 104.1.2. Okay. This is pretty much it. We're going to need to change our license levels. So what I'll do is I'll paste all this stuff in, and then we will change the license level. While it reboots, we'll jump into vManage. We'll get the C edge side configured. And of course we're getting CPU tracebacks, which is going to make it very hard to make sure everything here worked. But we can just do a ping. And just remember, this is all in the global table, so pings are in the global table as well. We are not looking good. Might be on the C edge side, though. kind of forget how far we configured this site. It's probably on the C-Edge side. Let's open up vManage. And this is C-Edge 8. So let's look at... Sometimes the data plane virtualization stuff on the Catalyst 9KV is weird and you have to bounce them to get it to work. That could be also what we're seeing, but that is rare. Helps if I'm under the right tab. CE8. Let's take a look at what we got here. 10.104.1.1. Okay, that looks oddly correct. We are on the wrong port. There are probably many people that noticed that before I did. There we go. We still need to attach an OSPF template here. So let's just take... It can literally be the exact same template. I'm just going to copy it for good practice though. I think we can use the exact same template as HQ. Yeah, we use G4 there too, so there shouldn't be anything we need to change. We'll just attach it. Oh, my screen seems to be... Oh, there we go. Okay. There we go. There we go. And you can start seeing the value in having all those templates available to copy and not customizing, you know, one template specifically for everything, and then it's all disjointed. Start with the base, copy them and tree them off from there, and it makes it a lot easier. So as soon as this is done, that should come up, and then we should be able to ping from the loopback of our FIAB to the DNA Center gateway. And it looks like we are still going on our DNA Center install. I did notice ISE is done uploading, so we can start that. It does take a while to boot up, and there's sort of an install process, so I'll let that start up. I just wanted to show you guys that I was doing that in case you're actually following along. I doubt there's anybody actually really following along to these, but in case you are. Okay, we see we have the route to DNA Center. So can we ping 172.16.129.1 sourced from loopback 0? And we can. So this puts us in a very good spot that when DNA Center is up and running, we should be able to adopt all of the nodes in the red boxes into DNA Center, get them provisioned to a site, and get the fabric site created. So in this video, I believe we are just going to stop at getting them onboarded into DNA Center, just so I can get this video out this weekend. I'm going to stop there. So we'll get DNA Center, we'll get ISE installed, we'll get these devices onboarded and provisioned, and then the next video we'll go through creating the fabric site and host onboarding and all that stuff. I just realized we forgot to change the license level of the FIAB, which is definitely going to be an issue, so let's just do that now before we forget. So license, boot, network advantage, level, network advantage, add-on DNA advantage. And now we hope and pray that this reloads and doesn't not come back up because of memory. Okay, it looks like ISE is up now, or at least ready for us to set up the appliance. Even though it's an OVA, and normally OVAs are packaged post-install, there's still a lot of stuff that ISE has to do in regards to like priming the database and applying the configuration that you give it after you deploy the OVA. So here we literally type setup in the login, so setup. And then we need to enter a host name, so yt-ISE. We need to give it an IP address. Remember, this is going to be in this network here. I don't know why this label is so off. And I'm not doing myself any favors here. Moving this box around. Let's get that back to normal. And then let's do what I was trying to do. And move that over there. Okay. So we'll make this 172.16.129. We made DNA Center 100. We'll make this 101. This stuff is very hard to change later. I would encourage you to make it correct now. Okay, so here's an issue we're going to run into. Our DNS server currently only has an interface in the network to talk to my machine. So we are going to want to go into our domain controller, DNS server, this multi-purpose box here, and give it another NIC in the VM that we are using, or in the virtual network that we are using. So let's add a network adapter, and let's put it in that same port group that's bridged in. And then let's jump in. Oh, didn't like that. Let's jump in here. And let's open control panel. This is that NIC we just added. The other one is on my CCIE network on my Underlay. 172.16.129.102. Make sure you make that mask correct. 172.16.120. Actually, we don't need a default gateway on this side yet. And let's just make sure. Yep, okay. So now we should be able to give it that name server, 172.16.129.102. We probably should have put our correct NTP server in there, but we'll see if it succeeds. Because I don't believe there's no way it's going to be able to get to that NTP server. While this does this, let's make sure we can actually, our first real test of our bridge. See if we can get out to that Windows box, and we can. So that was testing. Back to the PowerPoint just because it's easier. That was testing from here all the way through, because this is now DNA Center, ISE, and DNS on this other host. I forget if ISE checks the NTP server. If it doesn't, we'll be fine. If it does, we may have to enter. Yeah. Let's do it again. It might actually just let us continue here. While ISE installs, I'm going to do something else in this video that I didn't really have on the outline, but I think is really important. We're also going to install the CCIE Host VM, which is the VM you use in the lab exam to use Postman for API calls, to access vManage and DNA Center through. We're going to install that, and we're going to install it on this network here. So we are not going to put it inside a CML just because my CML is like struggling with the current stuff that's in it. We are going to install it inside of VMware. So let's get VMware back up here. And I will show you where you download this from. So you download this from, you can just Google CCIE Host VM, and you need the OVF and the VMDK. I'm not so sure you need the manifest file. It's very small, so I've always just downloaded it. So I'm just downloading the newest version. I don't know that this has changed since the last time I've downloaded it. There might be some newer versions of software in here. But it looks like this post was from a very long time ago, so I doubt that. But I'm going to let this stuff download, and then we'll just deploy this sort of like the ISE VM, except these are separate files, so we need to drag them all onto the screen at once when we upload them into vCenter or ESXi, whatever you're using. So I'll be back when this downloads. So it looks like DNA Center just finished installing. I think it's going to reboot now. While it does that, let's configure a DHCP server on our data center switch for this external bridge network. The reason I'm going to do that is because it's sort of like really hit or miss configuring static IP addresses on the CCIE Host VM. So I think it's easier if you just make a DHCP pool. So IP DHCP pool CCIE network 172.16.129.0. Oh, apparently there's multiple things that start with net. Okay, IP domain name CCIE.local. DNS server is 172.16.129.102. And default router 172.16.129.1. So we've just made a DHCP scope that covers this interface. So then when we spin up our CCIE host VM, it should automatically get an address because we're going to put it in that VMware port group that we created. Okay, so we have the CCIE host VM stuff downloaded. So let's deploy it. So this is where it gets a little interesting. So we're going to select all of these files here. So the manifest file, the OVF, and the actual disk. So it'll say we selected 3 files. That's good. We'll call this, just preface everything with YT that I use for this series so that I know what to delete after when I need disk space back. And we'll put it on that server. We'll just see where I have some disk space. I believe ISE is priming its database and DNA Center is coming back up after the post reboots, so they're both working away. We'll use this data store, and then we will put both of the NICs into our network that we created in the first part of this video. Now, just like ISE, we want to not close the browser until the OVF file is uploaded. It'll start showing up here under as a task, yep, right here. So this will need to upload fully, which is what uploads the disk to vCenter or to your ESXi host if you're using just ESXi, and then we will be able to start the VM. Okay, so that OVA file is uploaded now. So we see it right here. We should be able to start it and then console in. I believe this is just Debian with the desktop environment installed. There's no installation, it just runs. It is installed before it is packaged. Let's take a look. Make sure we actually got a DHCP address. And we did, we got .2. So we should be able to ping into the CML topology. Lovely, and we should also be able to ping ISE, or our let's go in order. So DNA Center, yep. ISE, yep, and our DNS server. So now from this central box here, which is the same OS you'll use in the lab exam, you can access all the resources. So this is what I think the amazing value of doing a lab like this is. You have a web-based console, just like the lab, and you have the same interface to work out of, just like the lab over here as well. So let's check. I believe DNA Center is still installing. ISE looks like it is installed, but it could still be starting services. Let's take a look. One thing to note is the browser is in a mode where it is always private. It's always in private mode, so even if you make favorites or don't rely on your history or anything like that, because it simply won't be there. So this is still initializing. I'm assuming DNA is not installed yet. Yeah, okay, so we're still waiting on DNA as well. We're still waiting on ISE, but we can get to both of them, and that is the important part. Once these two services are up, I will resume the video. ISE is up now. There's not much we're going to be doing with it in this video, but we can get logged into it anyway, just to verify functionality. I don't believe there's any sort of initial setup wizard. I think there's some little pop-ups you get, but I don't really think there's any initial setup it's going to guide us through. Yeah, these are the pop-ups I was talking about. But yeah, this is ISE. We're in here. We're not really going to do anything in ISE until the next video. You sort of have to get used to the fact that the screen resolution is not the best and the scaling doesn't really work right. We're going to have to wait until DNA Center is up to do the last step in this video, which will be onboarding our SDA nodes into our inventory, which should be very simple because we already did the bootstrapping on the devices. We just essentially have to run a discovery. Okay, I'm happy to report that the DNA Center machine that we started installing at 1:30 is done, and it's not even really done yet. It's still doing some tasks in the background, but I think it's done enough that we can finish the tasks that we need to finish with it. So I went ahead and I typed in our username of admin and the password that we set, and now it's telling us we should change the password again. I'm not going to, because we've already changed it from admin, and then we just need to agree to some terms, and then we get into this quick start wizard. I never use it. Maybe it'd be more useful if you were doing this in an actual environment where you had seed devices and you were doing LAN automation and stuff like that. This will go away. This automation and insurance services thing, that will go away. I believe we are going to have to wait until those background tasks finish to do any of the rest of this, so I will be back. Okay, after over 4.5 hours of installing, the DNA Center appliance is now fully ready for us to adopt our devices. So let's jump in. Let's make this a little bigger here. So we're in our host VM. Inside of our host VM, we are in the DNA Center web UI, and there's some stuff we need to do to start. So first we need to add an area. We'll call the area United States. So we essentially just need to build our hierarchy so that we can put the devices inside the hierarchy. So then we'll add a building, and we'll call the building CML headquarters. And you can just put in 00 for longitude and latitude. It'll just then make you select the country. And we will then add another building, and we'll call this CML branch 4. Once again, 00 is fine. You just have to select the country then because you can't auto-select it. And then if we expand United States, we should see both of our locations that we have in CML. The next thing we need to do is define some baseline network settings. Most importantly, the device credentials. We're going to come back and do our IP address pools and our AAA stuff in the next video once we get our ISE and DNA Center integration done. But in this section of the video, we really need to focus on the device credentials. So we need to, first of all, add CLI credentials. So we'll just name these CML, and it's DNA, and then our password that I use, which is ISE is cool. And just make sure you get these right here because there's no validation. And I do realize we did forget to specify an enable password in our Bootstrap. I'm gonna go back and do that in a minute, just so that if you do need it, I don't know if you need it if you set your privilege level on the console line, but I'm going to do it just in case. So this is the Cisco string that we set for our SNMP read. So read is required, write is optional. I do both. Not HTTPS, sorry. SNMP v2c write. Okay. Let's just get rid of this filter so we can see everything here. Okay. And then I think that is it. Now we should be able to see, yep, those credentials are applied here. So since we applied them at this level of the hierarchy, they should, yep, flow down. You see the inheritance logo here. So they're inheriting from the United States level. I believe you could have done that at global too if you wanted to do it if you had other countries listed here, but we don't. So now I'm going to jump back. Let's jump back into CML. We'll put this over here. And on our border control plane, we're going to need our border control plane, our edge, and our FIAB. And now we have to log in. No, DNA. Oh, and we forgot to set a host name on this one. Just make sure we still have the Bootstrap config. Looks like we do. Yeah, okay, we do. So, wanted to make sure we didn't forget to write entirely. Enable password. Just want to make sure that is on all of these. Oh, I don't believe I went into config mode here. Okay. Okay, so let's jump back into DNA Center. I want to make sure I didn't put Cisco here. I don't think I did, but we'll just edit it just to make sure. Okay, so now we can jump over to the inventory under provision. So this is where we'll be adding our devices. I have the new UI on. The thing to remember with this new UI, it's a little weird because you have this focus here, and what the focus does is it basically changes the columns. So think of this as like presets for the columns. So I usually use the inventory preset. I mean, you're in the inventory menu, so I really don't understand why the inventory preset isn't the default is okay, but it really doesn't show you anything, which is really confusing. So I have a list while I was waiting for DNA Center to finish installing. I made a list of our device IP addresses. So I'm going to use the loopbacks to adopt them, which also tests reachability to the tunnel endpoints, to the Lisp tunnel endpoints. So we'll select our credential here. We'll select our credential here. And then under netconf, we'll type in 830 because that's the default netconf port. I don't think you need to do anything here. They're already filled in. So we'll click add. So that, I believe, that was our border control plane node for headquarters site. Just give that 1 second, then we can move on. Okay. So next we'll add our, I keep forgetting I can't copy paste. Next we'll add our 10.254.254.2, which is our edge node at the headquarters site. So we'll just get these going here, the right credential. So I guess you wouldn't need the read credential at all because of the right one. It's probably the same thing as the Bootstrap config. You really don't need the read credential if you have the right one. And then the last thing we have to adopt is our fabric in a box. This is probably, yep, spinning right now. And if we refresh this, we could probably, yep, start to see our devices populating. So it's really easy as long as you use the same credentials for stuff. I mean, you could type them in manually here, but it's so much easier to just define them in the hierarchy and then reference them here, especially if you need to change something or if you type something wrong. I believe this one is adding now too. So we will just do an initial sync to them and make sure they all come up as reachable. It looks like we're good though. This is gonna take a minute, so I will come back when all of the columns are populated. So I'd like to show you a little issue that I'm running into. So if you see here, these two are fine. This one says serial number conflict. So it seems like I may have got the order of operations wrong when I was dragging the nodes onto the screen to change the serial number. So I have wiped our FIAB. I changed the serial again. I set it to randomize this time, so I just turned the bootstrapping off. And I wiped the node in CML, and then I rebooted it. And I still have the running config from when we did this one, because we did it last. So I added in the enable password that we had forgotten the first time. And when this boots, we can paste this back in. But what I'm going to do is remove this device, force remove this device from inventory right now. We don't want config cleanup because it won't be able to reach it. But I'm going to delete this device from inventory now so that when we add the new one, it's not a duplicate. So these two should be good. We're just waiting on this manageability to sync, but we may still be able to provision them to the site. So if we choose, it's going to look weird here because you think, okay, this is grayed out, so everything under it's grayed out, but it's really not. So these are our two headquarters. So we want to just assign all to headquarters, so that assigns both of them. And we don't need to tune anything there. Next, and assign. This is pretty fast to fail, so we'll know if we got something wrong here. It looks like, so that was our successful deletion of the one with the duplicate serial number. It looks like it did process. What I want to draw your attention to as well is this column that's all the way at the end. So if you were to use the default Catalyst 9000V images that are inside of CML, this would be unsupported. You'd see unsupported here, and when you try to provision, you'd also see unsupported in the device family. And when you go to provision it to a site, it would say cannot provision an unsupported device. So that's something to look out for there. Now, if you're using an older DNA Center version and a switch software that's too new but a model that is supported, you may see issues later on down the line, not necessarily here. So it may say supported here, but that doesn't necessarily mean it is supported for like fabric sites. So now we can look. I just want to make sure that that actually succeeded, but it looks like it did because we see that path here in the site column. Let's check in on. Okay, good. So now we have a random serial number. The other one's serial number, I believe, is my SDA serial. Yep. And I tried to make the other one my SDA serial too, the number 2, but it just made it my SDA serial again, and that's why we were getting that warning. As soon as this is done, we can paste in this bootstrap config. So no, we don't want to enter. Yes, we want to terminate. And let's just grab this. We might bombard it here. We also probably have to change the license level, but we'll bootstrap it, change the license level, reload. I'll pause the video, we'll adopt it. Just make sure I copied that. And now let's just do our normal sanity check where we ping from the loopback 172.16.129.100 source loop 0. Our OSPF adjacency might not be up yet. I believe there is. So it's these Catalyst 9000 V switches are very weird. There's a possibility that the control plane functionality of the switch is up, but the actual data plane isn't up yet, and that's exactly what we're seeing. See how this says down, down? Well, our link is actually up, but there's going to be a syslog message soon that says something like the data plane is actually ready, essentially. So that's what we have to wait for. While that happens, we can still do this. Boot level, boot license, I believe. Boot. Oh, sorry, license boot level. Network advantage. Add-on DNA advantage. I believe these are the messages. These are the syslog messages that I'm talking about. There should be another one though, because it's still probably not up. The only port up is the management interface because I don't think that goes through the virtualized ASIC. Okay, here we go. This is it becoming ready. So we should see our OSPF neighborship come up soon. Let's just end out of this so that we have our ping ready. And as soon as we see our OSPF come up, okay, there we go. And there is our reachability. So now we can reload to apply our new license level. And as soon as this is done, I will be back inside of DNAC. Okay, so the switch has just rebooted from us upping the license level. So now we should be able to add it back into our inventory with no serial number issues this time. So once again, we're going to add it by the loopback. Select our credentials. Fill out our netconf port and click add. And this is, I kept them side by side because I wanted to show you how you can sort of verify this is working correctly. You'll see a bunch of the security syslog messages for the user, the DNA user, whatever you give your CLI credential over here. You'll see that entering and exiting, and then you'll see some netconf sessions as it gathers data. So that should start to show up here soon. Let's make this a little bigger so we can see some more columns. This is going to take a few minutes to actually populate all of our data before we can assign it to a site. So I will be right back for us to assign it to a site. Okay, so we can see our FIAB's data now, so we should be able to assign it over to our branch 4 site. Okay. And it looks like that has succeeded. So now we have all of our inventory inside of DNA Center, and it is assigned to the proper sites. So basically all of our devices that we are going to need for our fabric are pulled into DNA Center. So now in the next video, when we want to make the red boxes fabric sites, we will be able to do that. So in the next video, we're going to start off by installing the SD Access app, because in the newer versions of DNA Center, there is actually, see if I can find it here. It might be, there is basically an internal app store. It's under software management. And it takes a while to load if you don't have internet, because it doesn't realize it doesn't have internet. We really want this bottom pane here, but it's going to wait until this top pane loads. there's an app called SD Access. We have to go in, tick that app, and click install, and then wait another maybe 30 minutes. So overall, the DNA Center install, if you include the SD Access app, takes about 5 hours. So just make sure, honestly guys, I would do it overnight. The first few times I did it, I hit the install button, I went to bed, I checked on it the next morning. I think that's the best way to do it. The SD Access app you can do during the day, like I said, it just takes about 30 minutes. But that is all for this video. At this point, I think we have a really good foundation for our CCIE Lab. We can start sort of tuning things and changing things, preferring some paths over other, filtering routes in certain places, doing sort of the macro segmentation stuff. So that's sort of what you could do with the lab in its current state. In the next video, we'll get it to a point where you can start testing out micro segmentation and host onboarding and the IP transit handoff between our SDA border nodes and our C edges. So I hope you guys enjoyed the video, and I'll see you next week in the next video.